Hey there, in this video we're going to learn how we can access the individual elements of an array using indexing and slicing. So let's start by creating an array. We can do this either by hand, but let's try out arange here. So we'll do numpy.arange 10. So this will give me an array that is 0 through 9. And since this is an integer value, it's an integer array. If I wanted a floating point array, I could add the dtype comma float. But for our purposes, it doesn't really matter here. So if I want to slice this, it's going to be the very same syntax as for lists or for strings. If I want to get access to the first element of A, I'll just use square brackets and then the index. So A0 here was 0, A2 would be 2. I can even use negative slices here if I want to work backwards. So A-1 would be the last thing in there, should be 9. Slices work just as well, so I could slice out 1 up through 4. And that should give me 1, 2, 3. Remember, we stop right before the last slice. Think of these as being pointers in between the elements. So it slices here, 1, 2, 3, stops at 4. So that's just the same as with lists. Now, unlike lists, the way we would slice a two-dimensional array is a bit different. For comparison, let's say I have a 2D list. We'll call it L2D for 2D list. Let's make it a list of lists. We'll make it 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I want to slice this, let's say I want to get 3 out of this. So if I do just a single slice like this, what it's going to do is I'm slicing the outermost list. So the first thing in the outermost list is the first list here. And so then if I wanted to get to the last thing in it, that would be element 2. So I'd attach a second slice here, and that would let me get to 3. So the way you would do slicing a multi-dimensional list is you just have multiple square brackets with the index you want. Let's make a two-dimensional array. In fact, we can build it off of that list I already typed out just to save a little bit of typing. Okay, so we can see there's our two-dimensional array. Again, let's say I want to get to 3. Let's try it the other way. So let's just pretend it was a list. If I slice 0, 2, does that work? It does. But there's a better syntax, sort of a more compact syntax for arrays. Keeping the order here can be a little bit hard to wrap your head around unless you're really thinking like lists of lists. So the other way we can do this with arrays is we can do just a single set of square brackets and have a tuple in here asking for what we want. So if I put 0, 2 in here, so it's effectively a tuple, then I'll get 3. Okay, so with arrays we can use tuple slicing, whereas with lists of lists we didn't have that option. We're mostly going to work with arrays, so you don't really have to worry too much about that first notation. Now where this really comes in handy with our arrays is, let's say I want an entire row or I want an entire column. Remember how when we do slicing with lists we had colon representing like a range or all of? After all, if I did, do I have a list defined anywhere here? Well, I have A defined. So if I do A colon, that's shortcut for just give me the whole thing. So with A2D, I can put a colon in my tuple. So let's say I ask for everything for my first index here and then 2 for my second index. What that's going to give is 3, 6, 9. So it basically just sliced down the column. It said, I want to look at every row, but I only want column 2. The order of these indices, after all, is row column. The other way around, if I do 2, colon, what that says is just give me row 2, and I want all of it, 7, 8, 9. And we can do this also with start points and stop points before. So let's say I want to slice only up to, let's say only up to element 2. So that should only give me 7, 8. 7, 8. Typically we're going to use this kind of notation though if we want to slice an entire column or an entire row out of an array. So the next thing I want to look at is some fancy array slicing that can be kind of handy for filtering your data. So remember, we had an array A that was 0 through 9. Let's see what happens if I write a statement like, show me where A is greater than 5. How do you think Python would interpret that? You might think that it's trying to compare an entire array to 5, which would be a nonsense kind of statement. And since it's nonsense, it takes a different interpretation. It says element by element is my array greater than 5. So if I run that statement, I get another array. It's going to be an array of true, false values. In this case, false, 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 all the way up until we get to 6, and then that's true. So where this is really powerful is an array of true, false values can be used with slicing. Let me show you a shorter example. Let's say I make an array that just has 3 things in it. We'll go 1, 2, 3. So I'm allowed to slice that with, let's say I make another array here, a mask array, and in that I'm going to put some trues and falses. So let's say I do true, false, true. So it's legal to slice B with this masked array, or with this mask, which is an array of true and falses. If I do that, it only gives me the elements that I marked as true. So I said number 1 is going to be true, 2 will be false, don't include that, 3 will be true. So if we combine these ideas, I can do something like, give me A wherever A is greater than 5. And that's really powerful, especially if you have some kind of values you're trying to strip away from your array. Like say I don't want the negative values, I only want positive. Then you could write this, give me A wherever A is greater than 0. And you can mix and match, kind of like we did here with mask is just a completely different array. So let's say I had an array C, and we'll make that equal to, okay, let's make it an A range. Go 10 to 1 and steps in -1. See what that looks like. Okay, so give me A wherever A is equal to C. And, oh, I guess it's not equal anywhere. That's unfortunate. It's because, I guess we just never line up anywhere in this array. Okay, how about we do give me A where A is greater than C. That should work. Oh, that's why it's yelling at me. This is a different length. Okay, my bad. Let's recreate C so that it's the same length as A. Okay, now I should do A where A is greater than C. A is greater than C down here near the end. So the 6, 7, 8, 9 is greater than the 4, 3, 2, 1. More typically, though, you would use this kind of notation where you're trying to pull out certain values of an array based on them being greater than or less than some kind of sentinel value. So in this video, we looked at how we can slice arrays, how in one dimension, slicing an array is a lot like slicing a list, identical syntax. In 2D, you can use the same syntax as for a 2D list, but much more common, much more powerful is slicing with a tuple. Remembering that you can use colon to represent an entire row or an entire column, with the order of these indices being row column. And then we looked at how you can do some fancy slicing by doing a comparison with an array, which quietly creates an array of true false values, which are legal ways to slice an array. So you can do things like give me A everywhere it's greater than 5.